Recording, great. Good start. Oh, there we go. All right. So 8.1 is, I think, a pretty easy topic. It can seem a little confusing, but once you get the hang of it, it's pretty easy. 8.3 is definitely the most confusing. So what we're doing next week, we're doing 2 days of it because it's pretty confusing. But this one, I think, is pretty straightforward. So let's talk about direct, inverse, and joint variation. We'll start with direct variation. So let's think of what those two words mean. When you hear the word direct, what do you think of when you hear the word direct? There's a lot of different ways. Being very straightforward, or someone's being very direct with you, but probably being very honest, right? And very transparent. Or, you know, just you're not being around the bush, getting to the point. That's kind of what's happening with this stuff. And then variation. When you hear the word variation, what do you think of? Multiple like variables. Also change, right? Like how things are varied, right? Because yeah, variables change, right? So we're looking at things change directly, right? So this is what this is all about. It's about direct, or let me changing in a direct manner. If that makes sense. Let me give you a good example. Let's say you stand outside and so who's Matthew, are you 6 feet tall? Okay, let's say you're 6 feet tall. Let's say you stand outside and your shadow is 12 feet long. Now you stand next to a tree. Let's say the tree is 30 feet tall. How long would this tree shadow be? 60. Because what did you do? You took the ratio, right? Your shadow was twice as long as your height. The tree shadow should also be twice as long as its height, right? That's direct variation because you're looking at a direct comparison between those two things, right? So generally speaking, the formula would be this. The formula is y equals k times x, where k is called the constant of variation. So that example I just shared with you guys, let's say x.
Wait, doesn't it? No, doesn't it say a is the constant?
I use k instead. It says a. I like using k. K is more common.
So when we see a, no.
It's the same thing. I use k though, just my notes. But yes, in the print, you're right, Patrick does say a. By habit, I use k. My k, actually, I should use a because I don't do a good job drawing my k's, but whatever. So anyway, in the example I just shared, right? Like, let's say x is your height and y is your shadow length. So then I say earlier that let's say your shadow is twice as much as your height. So Matthew's 6 feet tall, his shadow is 12 feet long. A nearby tree is 30 feet tall, its shadow is 6 feet long. What would k be in that situation? 2, because that's a constant, right? Because consistently, your shadow is always twice as much as your height, right? So that's a constant of variation. And believe it or not, a lot of things you guys have done without realizing it have followed this formula. For example, circumference. Does anyone remember the formula for circumference? 2 pi r, or how about in terms of diameter, what would it be? Pi d.
Yes,
Exactly. So in this case, that is your constant of variation, the pi. So what happens if you double the diameter? What happens to the circumference? If you double the diameter, circumference doubles. If you half the diameter, circumference halves, right? That's called direct variation. Or for example, does anyone have like an after-school job or weekend job where they make money? Oh, okay. Well, let's assume you do. Okay, that's okay. You guys might be a little too young for jobs. Let's say you go work like at Stanford Mall, like some retail, and you make like $20 an hour. That's a pretty good. Or babysit. Is it a babysit? There we go. Okay, good. You charge by the hour, I'm assuming, right? Mm-hmm. And you probably charge the same rate per hour, right? So, okay, great. So if you make $20 an hour, if you work more hours, guess what? You make more money, right? So like, for example, the amount you make times, say, $20 times time, right? That's your constant of variation, right? Your amount goes up if you work more hours. So it's a very simple, very, very simple formula. So let's do actually another problem here. Let's look at driving. So you drive 50 miles per hour consistently. So it's a constant. So your speed doesn't change. So like maybe hit cruise control in the car and it just goes the whole time. So distance varies directly as number of hours. So you guys seen this formula before? D equals RT, right? Distance equals rate times time. So that's direct variation. What's our rate again, or speed here?
50 miles per hour.
50, there you go. That's it. And the constant variation is 50. That's all. So don't overthink it. That's all it is. In chemistry, have you guys done gas laws?
We're doing that right.
PV equals nRT, right? I'm going to come back down a little bit, but that's also a great example of variation. All right, let's move on to inverse variation. Okay, inverse variation, as you can tell from the name, sounds like it's the opposite. So it's basically when it's, and I'm going to use K instead of A. I just like using K. So the formula is y equals K over X. And K is still the constant of variation. So what this means is that when X goes up, Y goes down. But in a proportional manner. Okay. I know there's a lot of people doing construction around here. Does anyone have their house remodeled or have like things done to like construction guys, right? Okay. So let's say you're redoing your kitchen. Your parents hire some guys and say, okay, the contractor says, I'm going to bring 2 guys. They're going to get the kitchen done in 4 weeks. Your parents are like, no. We can't have the kitchen out of commission for 4 weeks. We want to get done sooner. So if it takes 2 guys, I'm going to just put this down. You don't have to write this down, but if it takes 2 guys 4 weeks, right? And your parents are like, no, this is no good. We want it done in 2 weeks. So how many guys do you need then? 4 guys, right? So guess what? The time went down by half, but what happens to the number of guys working on the kitchen? It doubled, exactly. What's the opposite of multiplying by 2? Divided by 2. Are those inverses? They are, totally. Whereas like with Matthew, his height to his shadow length in the tree, I multiplied by 2 in each case, right? That's a direct operation I did. I multiplied Matthew's height by 2 to get shadow length. I multiplied the tree's height by 2 to get shadow length. That's direct variation. This is inverse, where I'm going the opposite direction, but proportionally, right? Or what if your parents are like, no, we have a big party coming up. Like, no, we gotta get this done even faster, right? I want it done in 1 week. How many guys do you need? 8 guys. Why 8 guys? Well, go from 4 to 1. What do I divide by? So what's the opposite of dividing by 4? What's 2 times 4? 8. That's inverse variation. Also, the fact that if you have y equals k over x, k would be x times y. So you need the product to be a constant. For example, 2 guys, 4 weeks, that's 8. 8 guys, 1 week, that's also 8. So that's what's happening there. Excuse me. So that's, whereas the direct variation was this, y equals k times x. So k is y over x. So in that case, that's a constant ratio. So I'll tie this all together when we finish these examples so that you get all of them straight. Let's look at example 3 here. A family plan has 20 gigabytes of shared data. What is the relationship between the number of people on the plan and the data limit per person? The relationship is going to be inverse. And it's going to look like this. The data will equal k over the number of people. And sorry, this is the data per person. Let me add a little wrinkle to this. This is the data per person. So for example, how much data do you have total? So that's your constant, 20. So for example, let's say I didn't have a family plan for my cell phone, right? So I'm one person, right? So how much data do I get to use? 20, right? But then let's say my wife joins my plan. How much data do we each get now? 10, that went down, right? And actually kind of crazy, but my in-laws are actually on my plan. Don't ask why. I think because they want to save money. But so now that's 4 people on our plan, right? So how much data do we get now? 5, right? So see, the number of people went up, but the data per person went down, right? And that's because there's an inverse relationship. The next one's probably a little bit better. I didn't make these notes. I think Ms. Wong did. I think she just when she was before she got married. But it takes me 5 hours to clean my house. If I get my fiance to help me clean it, it takes us half the time. Is this direct variation or inverse variation or neither? It's going to be inverse. Right, exactly, because the number of people doubled, but the time to do the job was halved. So went opposite directions. So you write an equation, you could say P equals 5 over T, where T is time and P is number of people. By the way, it could have been reversed. It could also have written like this. T equals 5 over P, same thing. That's an alternate solution. So I do need to get camp set with this test. I'm gonna have you guys try some problems, see how it goes. Identify which ones are direct, inverse, or neither. You can talk to your partner about it. I'm gonna pause the video just for a sec. All right. So that's inverse. And the reason why is because this could be rewritten as y equals 7 over x, which is just like y equals k over x. Plus the fact is this, what if x were 1? 1 times 7 is 7, of course, right? What if I make x 2? What's y gonna be now? 3.5, right? So by doubling x, what happened to y? Got halved. Opposite direction, inverse. So that's inverse. Also, I'm gonna explain the direct ones and the other ones in a sec. Also, this is the part that I really tie it all together. Inverse has to be a constant product. What does product mean? Multiply. And are we multiplying x and y? Yeah. And is the product a constant? Is 7 a constant? Yeah. Right? This is gonna be 7 the whole time when you do x times y. So that kind of ties it together. Now, D, what do you guys think D is gonna be?
Direct.
That's direct. Because it follows the form y equals k times x. Also, y over x equals 2, right? Y over x equals 2. That's always going to be a constant ratio. Just like the tree and its shadow length, or your physical height and your shadow length, right? That's always going to be a constant ratio. What's the ratio for y and x here? 2, right? So for example, if x were 4, what would y be? 8. If x were 10, what would y be? 20. 20 over 10, 8 over 4, both 2 to 1, right? So that means that E is also going to be direct. C is going to be inverse again, because it follows the form y equals k over x, or x times y equals a constant. So whenever the product of the two variables is a constant, that's inverse. Whenever the ratio of the two variables is a constant, that's direct. Or y equals k over x is inverse, y equals k times x is direct. Now, these other two that I didn't answer yet, they're both neither. Let me explain why. Excuse me. For part B, let's say I do an xy table, right? The equation is y equals x plus 3. Let me pick some random numbers for x, like 1, 2, and 4, right? Not totally random, but what's y going to be when x is 1? What's y going to be when x is 2? What's y going to be when x is 4? Okay, now compare. What's the ratio in the first grouping? 1 to 4. What's the ratio in the second grouping? Not the same ratio, right? What's the ratio in the third grouping? Not the same ratio. Let's look at the product. What's 1 times 4?
4.
What's 2 times 5?
10.
4 times 7, 28. Also not the same. That's why it's neither. Even though it's linear, but the fact that at the x, the plus 3 throws it off a little bit. So the other thing you have to understand too is that for direct variation, you need to have a y-intercept of 0. What's the y-intercept for part B? Not 0, right? It's plus 3. So that's the other thing too. By the way, on the SAT, which I know the sophomores will do next year, or the PSAT in the fall, they do ask these questions like, they'll give you a table and say, hey, does the table represent linear? I mean, does the table represent direct variation? Or pick the table that has direct variation. Or pick the table that has inverse variation. They do ask that question. I've seen it. Now F, why am I saying neither for F? What's going on with F? What throws it off there?
That's the root.
This, yeah, the exponent, yeah, or a root, same. It'd be, you know, a square root would be the same issue. You can't square for direct or inverse variation. Plus, if you made a table, right? What if we did 1, 2, and 4?
Wait, what if they're both? Oh, never mind.
Both what?
I was gonna say, what if they're both squared?
Actually, if they're both squared, then it would be back to linear or back to direct. Yeah, because you square root. But like, what's the ratio here? 1 to 1. What's the ratio here? 1 to 2. What's the ratio here? 1 to 4. Different, right? The product's 1, 8, 64. Forget it. Okay. Just so I pace myself appropriately. Cool. Yeah, we'll get these done. I don't know if I'm gonna do all the. We'll stop around page 3. I think that's good enough because I have classwork for us to do. So let's look at these examples here. Okay. So what do you guys think for number 2 here? Right equation relates x, y. What relationship do x and y have here? Inverse. So how am I going to write my equation if it's inverse? Y equals what? K over x, good. But then let's figure out what k is. How do I figure out what k is? How am I going to use the other information to help me?
Well,
Totally. Totally. Thank you, AJ. That's perfect. Yep. Just plug it in. What's k going to equal, guys? 28. So what's the real equation? Y equals 28 over x. Does that make sense? How I got 28? Plus, here's another thing to do. What's 7 times 4? Well, there you go. I multiplied because it was inverse. There was a constant product made of inverse. So that's part A. Right, that's part A. And my constant variation, of course, is 28. Now, let's look at part C. Find y when x equals -2. So that's too easy. What is that going to be?
Y equals -14.
Boom, got it. Told you stuff's not that hard. It's really easy stuff. There we go. Okay, let's try it again for number 3. For number 3, you're varying directly, right? So how am I going to write that equation? P equals what? Go, Patrick. Yeah, actually, there's yeah. Let's let's change this to let's change to an X. Let's change it to an X. Let's change the K to an X here. It's just confusing. Let's change the K. Yeah, because I use K. I don't like using K. See, they use K in number one. Anyway, we're gonna say P equals K times X. So now, let's get the equation. 12 equals K times 4, right? What's K equal, guys?
3.
3. So your equation is Y equals, not Y equals, P equals 3X. There you go. Constant variation, of course, is 3. And then solve for P when X is -2.
P equals -6.
Boom, got it. That's all. And now let's get to stuff that you guys have seen, like chemistry, right? So you guys learn about like Boyle's law, Charles' law,
Yeah.
yes. Gay-Lussac's law. Do you guys know that one too? Okay. So there's all these different laws of, and then ideal gas law. Ideal gas law will hold off to near the end. So we told that pressure and volume, which if you think about like if you have like a balloon, if you put more, well, hold on, yeah, the inverse of each other. Sorry, I'm just trying to wrap my, let me let's just do the math first. I was gonna do the chemistry with you guys, but I don't want to mess it up. So they vary inversely. So yeah, what this means that if you have like, yeah, if you have bigger space, right, you don't have as much pressure because the molecules are all bouncing off everywhere. But if you have a tighter space, the pressure gets higher, right? It's more compressed. You want to think of it like that. So pressure is going to equal K over V, or P times V equals K. And you don't have to write this down, but you guys have seen this in your chemistry class, like P1, V1.
P equals P2.
Yeah, same thing. Same thing. It's not any different. Yeah, like P1, V1 equals P2, V2, right? Same thing. So there you go. There's your formula. Done. That's all. Okay, joint variation. That's when you're looking at multiple variables. And it's when multiple variables are varied directly with one other variable. Oh, you're done? Okay, great. Yeah. So joint variation, I think a good example. I can't think of a good example off the top of my head, but it's when Z, like in this case here, Z varies directly with both X and Y. But we say jointly instead. Because more than one variable. So we say jointly instead. So like if X were to double, Z would double. If Y were to double, Z would double, right? Actually, I did think of a good example. Let's do, I'll do it on the board. Okay, let's go back to construction again, right? So let's say C is the cost of the kitchen remodel. Equals K times number of workers times let's see here, hourly rate per worker. Okay, so let's say you hire 4 guys to remodel your kitchen, right? And let's say each guy charges you $50. So it's going to cost you $200, right? But what if you double their workers and you double the price? So now in this case, it went up 4 times as much, right? Or let's say you kept the price the same, but double the workers, then it doubled, right? So both of these vary directly with this, but you combine it in such a way to have one formula. That's all. So it's not that much different. Like for example, let me look at part B. W is going to equal K times X times Y times Z. That's it. That or
Did you just put those all together, like how they did? And
yeah, you could do that. You could do W equals KXYZ. Sure. Yeah, same thing. Now let's look at, and we're using K again, not A. We use K, not A. Bless you. All right, let's look at part A. If you vary inversely again, that's Y equals what?
over.
K over X. Now this is where it gets a little dicey. I need some space here. So Y varies inversely, so Y equals K over something. What am I gonna put in the bottom? X squared, good. Of course, because they said so, right? Just do what you're told. Let's look at D. Z equals K times Y, because the Y has to be up top. And what goes in the bottom? Because it's inverse, right? Whenever you have multiple variables where one's direct and one's inverse, so we put the direct in the numerator. We'll put the inverse in the bottom. Because if Y doubles, I want Z to double. But X gets doubled, then Z is going to half, or vice versa. And then lastly for E, X varies jointly with T and R, so X equals K times T times R. But where's the S go? Underneath. That's all. Yep. Let's do a handful of practice questions, and then we'll do the class workout. So I'm not going to do all these because I have other stuff to have you guys work on, but let's look at these 4 here. Excuse me. You vary inversely. So give me the equation. Y equals what? K over X. And then substitute the stuff that you're given. What's K gonna equal, guys? Perfect. So your equation for part A is Y equals negative 24 over X. Now let's look at part B. What's Y gonna equal when X is 3? Boom, got it. So that's parts A and B. All right. Once you guys try number 2, I'll give you guys a moment to do that. You can check with the person sitting next to you. Then we're gonna compare. And by the way, your test, I'll give that to you guys on Friday. There's still other people in the class that haven't taken it yet, so. Excuse me. Negative 2Y? That's negative 24.
Oh, sorry.
My handwriting sucks. No, I need to do better. Well, thanks. Okay. So negative 24. All right, let's look at part A. What do you guys say Z equals here? Perfect. And the sub stuff that we're given. Be awfully careful with the fraction arithmetic. I think, is it 20, guys?
Yeah.
Good. Okay. So your equation z equals 20xy. So now let's look at part B. So z equals 20 times -4 times 5. What does z equal? -400. Yes, very good. Perfect. Again, this is stuff that can appear on an ACT or SAT exam. Just good stuff to know. It's somewhat tied to what we do later in this unit, but it's really more just you gotta check off this box. Like we gotta talk about variation. So that's really just be honest. It's not as crucial as the other stuff we do down the pipeline in this unit. All right, let's do a couple more and then we'll do the classwork. We won't do page 4 of these notes because I kind of have other stuff we can do. All right, let's take a look at number 3. So write an equation relating x, y, and z, given that y varies jointly with x and square z. So y equals what, guys? Y equals what? X times what? Z squared. Only the z squared, right? Not the x. Only z squared. Let's look at number 4. Write an equation relating w, x, y, and z. So w equals what? XZF's up top. What goes down below? And it's just y. Nothing's squared or rooted or anything like that. Yep. Good. Okay. So now what we'll do, yeah, we won't worry, but maybe we could come back to this page later on when we do some review. What I want you guys to do now is work on the classwork. And by the way, the classwork you guys did through previous unit and other units, I'm giving you credit for that. I just got punched into Schoology. I've seen you guys do it. You don't have to submit it. I watch you guys work. Homeworks as usual. Make sure you keep uploading them. I need to grade the homeworks. I know that's on me. But what I'm gonna have you guys do is, so you have 2 problem sets. You're gonna work on the one that says classwork right now. It should take not that long, maybe 10, 15 minutes. You're simply working on the one, and by the way, I labeled all the dates too. Unless if something happens, I don't think we're gonna have 60-mile-per-hour gusts. Actually, let me stop recording. You know, I'm not. I'll